Salutations, my fellow ICT aficionados. How's everybody doing tonight? All right, so starting to see some comments already starting to come in. Welcome. So before we get started, number one, make sure that if you haven't already, that you sign up for the Field Wax giveaway. The address for that is bit.ly/CBRCDD. All you do is enter your email. You'll be notified when after hours are done, and then you'll also be notified when podcasts are done. We're starting a new series, project management series, 5-part series. I did publish the first one last night on definitions. What's a project manager? What's a project? What's project manage? The second episode, which will be this coming Monday, will be on stakeholders. What are stakeholders? What do they do? What are their roles? What's an internal stakeholder? What's an external stakeholder? Episodes 3 and 4, we're going to go through the project lifecycle, initiating, executing, controlling, and close. I'm not sure which ones will fall where. We'll go in order, but I'm not sure exactly how they'll fall out yet because it just kind of depends. And then we're going to talk about, in the last episode of the project management series, we're going to discuss project management certifications, the Big C RTPM, Registered Telecommunications Project Manager. And then we're also going to talk about PMI's, Project Management Institute, PMP certification. And we're going to talk about which is best. I'm actually got a couple of interviews lined up for part of that podcast. So that one might be a little bit longer than normal. I got a friend who's got a PMP certification. So he's already agreed to do an interview. And I'm looking for someone who's got that Big C RTPM certification. So if you have that and you don't mind answering 4 or 5 questions and being a part of the podcast, because we want to know, well, what has that really done to your career? Make sure you also check out our new webpage, 5minutercdd.com. We've got it all laid out. All the podcasts are on there. All the recorded after streams are put there afterwards. There's a spot for you to submit voicemail, spot for you to submit email comments. There's even a page for you to submit your work. Are you brave enough? Yeah. Submit your work to a former QA inspector. Yeah. No, actually, I'm pretty nice about it. I'm not going to beat you up if there's all kinds of stuff going on, but hey. So tonight's subject was done by special request months ago. When I first started doing this podcast, he asked if I could do this, and I told him I certainly would. I'm just now finally getting around to do it for him. And what was that podcast about? Because you probably, the LinkedIn thing says, what does these 3 things have in common? One was a ring, one was a star, and one was a bus. And you probably already got it. They're all topologies. So there you go. So welcome, Miguel Angel Oka. I hope I said that correctly. So welcome, George, and everybody else who has joined. So I didn't even saw that. I just talked about we're doing a project management series on the podcast. So tonight's, like I said, is going to be about topologies, cable topologies. But before we get started, you got to do the right thing, right? What I always do on every Thursday night, right? What are you drinking? Right? It is after hours, so it is okay to be drinking adult beverages, although I'm not. Ice water with lemon essential oil. Put in the chat box, what are you drinking tonight? It's okay if we're drinking something strong or not. It's fine. But it's funny, when I was teaching a class today, I was drinking, because I drink water while I'm teaching class virtually, and I wasn't even thinking. I kind of reached up to get a drink, and one of the students says, "Are you drinking moonshine?" Yeah, no. I'd probably be more interesting if I was drinking moonshine, but no, not drinking moonshine. It's just water. I'm on a very strict keto diet. Although my wife and I did venture away for about a week, and we ate bad for about a week, and boy, did we feel that. So what's everybody drinking tonight? Or if you're not drinking anything, just say, "Hey, Chuck, I'm not drinking anything tonight." Right? So here's what we're going to discuss tonight. My goal is to get done with this by 6:30, and then maybe open up for questions. So we're going to talk about, number one, what is a topology? Because a lot of people don't know what that means. We're going to talk about how it fits in the OSI model. And then we're going to talk about a bus topology. For each one of these topologies I'm going to cover here, we're going to talk about what it is, the advantages and disadvantages. So we're going to talk about a bus topology, a ring topology, a star topology, and hybrid topologies. So we got a lot of stuff to cover. So, again, if you come up with your questions, make sure you put them in the chat box because I am watching both at the same time while we're doing this. So what is topology? So topology is just water. He said he's driving. So Miguel says, still working hours at his zone, and he got to drink it and drive back home. So it's just water. Yeah, don't be drinking and driving. We want you to be around for a long time. So topology is just a fancy word for cable and connectors, the stuff that, patch panels, patch cords, the things that connect all the hubs, the routers, the switches, the workstations, the nodes. When you look at the OSI model, the OSI model tells us how a network processes information. So it starts at the computer on one side at the application level, and you can see the funnel on the slide there. It works its way down through the funnel till it gets to what's called the physical layer. And that's where we spend most of our time, is on the physical layer. And then, so it does, it provides connectivity between one unit to another. So for example, let's say you have 10 gigabit base T Ethernet. So you got a piece of cable. It connects us together. So what happens is the transmitter takes all them ones and those zeros and puts it into a packet. It puts a start bit on it. It puts a stop bit on it. And then it transmits that signal out of that cable. That signal goes through the cable. And then when it gets to the receiver takes in that information. It strips off the start bit and the end bit, processes that information. And then it also sends a signal back to the transmitter saying, okay, got it. We're ready for the next one. So that's the physical layer. The physical layer, if anything goes wrong with it, it can cause all kinds of problems. All kinds of problems. The first one I want to talk about tonight is called a bus topology. Now, you don't see bus topologies too much anymore, but when I first got in the computer cabling industry and the telephony industry, it was the cat's meow. It was used everywhere. It was used for thick net, thin net, residential telephony, and point of sale systems. Now, I got them broken down separately like that because they're differently. So for those who may not know what a bus topology is, so when you're looking on that screen, you see those 5 computers. And those 5 computers are all connected together via a single cable. So cable comes from the first computer, comes out, goes into the second computer. And then another cable comes out of the second computer, goes into the third to the fourth to the fifth. And it does that up to 64 devices on some particular types of LANs. The cool thing about this is they're really super easy to install because your run lengths are generally extremely short. Because when you're wiring up a commercial office building, think of this: you got a row of walls for offices. You're literally just going from this wall to the next wall, and then the cable goes from the next wall to the next wall. So they're a series of short runs. So they're really easy to install. What happens is generally the server will send out a signal, and each one of those computers, each one of those workstations there is a node. So when the server sends out a signal, it's addressed to one of those specific nodes. Let's say, for example, this one is a node number 5. So it wants to send an email to node number 5. So it puts that information in a packet. It sends that information. When it gets to the first device, it's like getting a letter. They look at the address. Oh, that's not me. So it puts it back in the mailbox. And then the post office comes by, postwoman comes by, takes it out, puts it in the mailbox of the second one. And it works its way through to finally when it gets to number 5, that node looks at it and goes, oh yeah, that's mine. And so it reads that information. So like I said, they're really easy to install. The disadvantages to bus topologies: they're difficult to expand. Now, one of the biggest ones, for example, let's look at thicknet. Or no, let's do thinnet first. So thinnet was a coax cable, and you just ran it again from the first device to the second device to the third device, and worked your way down. When the project was done and turned over to the customer, 6 months, a year down the road, the customer decided they want to add another drop. Well, in order to add another drop, you have to know where that last location is, right? Because you have to extend off that last location. Not a problem. All you need is a copy of the as-built that were given to the customer after the project was done. You know what an as-built is, right? That is, an as-built is that documentation that they lose 3 days after you give it to them. So now they don't have the as-built anymore. So now what you're going to have to do is, as a technician or service tech, whatever role you happen to be playing this particular day, because we all wear multiple hats, you're going to be popping ceiling tiles everywhere to find that drop that only has one cable going down the wall. Once you find that, then you're going to run a cable from that drop to the next drop. Now, if that drop is nowhere near it, you can do it in the center, but now you got to run two cables because you got to pick your device and then run two cables from that new device to that old device, and you got to replace cables. So they're not the easiest thing in the world to troubleshoot. Another thing with bus topologies, because typically you're talking about baseband communications, is they can be very difficult to shoot. So when that signal gets shot down that cable, if there's not a resistor at the end of that cable, that signal gets reflected back. That's called return loss. Well, when that comes back, then it starts confusing the workstations on that bus topology. So that causes problems. So what that resistor does is it absorbs that signal so it doesn't bounce back and forth on the cable. So the signal direction is just going one direction all the time, because it basically is like, throwing a golf ball into a body of water. It just poop and disappears. It doesn't come back and cause any problems. So when you're troubleshooting, and the thick net, that's also a bus topology, but thick net's different than thin net. It is a coax cable, but it's a huge coax cable. Thick net was actually designed to connect copiers together for like law offices and stuff, where they've got to connect all their copiers together. So when the paralegals make copies, they can put in a job number on the copy machine, and then that customer pays for that copy service. So they would run this really big, thick cable. It was usually orange in color, and you would run a big ring around the floor. And then you would have to run these things called transceiver cables. So the transceiver cable, there's a device that you actually clamp onto the cable, and then there's a little tool. It looks like a screwdriver, but without the screwdriver part. It's got a little kind of like miniature drill bit hanging out the end of it. And then you actually had to stick it in that transceiver case and then hand drill. It was called a vampire tap. And then you would connect that. You would turn the heartbeat on or turn it off, depending on which kind of network you have. And you would run that transceiver down the wall. And the transceiver cable was a 12.5 pair cable, not a 25 pair cable like telephony, but a 12.5 pair RS-232 cable, which was extremely big and thick and bulky. And then you would connect that to the device. That one was probably the easiest of all of the bus topologies to do, because when you pop open the ceiling, you'd see that big, huge orange trunk cable, and you could tap in anywhere. Where the thin net, you had to find that last drop. And probably the most common use for bus topologies is residential telephony, especially the older houses. The newer houses, they're doing a star topology. We'll talk about that here in a minute. But a lot of the older houses, they did bus topologies. What they would do is AT&T or whoever the service provider is, they would run the cable into the house, and generally the phone in the kitchen or the drop on the kitchen wall was the main one. And then they would run a cable from there to the first bedroom, a cable from the first bedroom to the second bedroom, and then they would daisy chain through the house. The advantage there is it's kind of easy to do. The disadvantage there is if something goes wrong with the cable, you have to troubleshoot each of those segments and try to figure out where it is. And that's kind of why you'll still see bus topology in limited areas, but they're still out there. You still may come across them. Whoops, went the wrong way. There we go. Ring topology. So what is a ring topology? So ring topology usually used with IBM token ring. You're doing, type 1, type 3, type 9. But again, a lot of people think this is old technology, but a type 1 cable actually had the performance of 600 megahertz. 600 megahertz. You heard me right. It was better than Cat 6A cable. Cat 6A cable is only good to 500 megahertz. The problem with type 1 cable was it was big, it was bulky, it had a shield, it had a connector on it. The connector was actually called, I'm going to use a big term for you, it was actually called a hermaphroditic connector, because it was neither male nor female. And you can plug two of them in together. With like RS-232, you need a male connector and a female connector. With coax, you need a male and a female. With UTP, you need a male and a female. Well, with type 1, you didn't. It was a hermaphroditic connector. So what they would do is they would run a cable from that first computer to the second computer, and then another one from the second to the third, fourth, just like the bus. But the only difference is on that last workstation, they would bring a cable from that one back to the first one, creating a ring. That's the difference between bus and ring. Here's the tricky part about ring topologies. You can have a physical star, a physical ring. I'm sorry, you can have a physical or a logical ring. A physical ring means literally the cables form a ring, right? The logical ring, now you're talking about, there's a piece of equipment, two of them actually, and they were called a MAL or a CAL. And the acronym is MAU or CAU. And I can't remember off the top of my head what that acronym meant. So what you would do is you'd actually run those cables in a physical star topology, but the equipment treated it like a ring. Now, the advantage there is when you're doing ring topologies, the physical ring topologies, again, easy installation because your runs are going literally from this wall to that wall really easy, and they're coming back again. So it made doing moves adds changes pretty easy as well. The disadvantages to a ring topology is, and this is actually also true for bus topologies, I forgot to point this out. If something happens to this computer, the person who sits at that desk, let's say that they threw the briefcase up underneath the desk and they threw it a little too hard and it hit the faceplate and busted it, the whole entire network goes down. The whole entire network goes down. Same thing with the bus topology. So you got to be really super careful with that. And now, a problem that you have with ring topologies that you don't have with bus topologies is as that signal goes around that circle, you could have data collisions because that data is circulating in a ring. And that could cause errors when you go to have, send emails and stuff. The primary type of topology that's used today, or used the most today, is called a star topology. Now, this can be a couple of different kinds. It can be a star, a hierarchical star. It can be a tree, but they're all basically a star. So every cable runs back to one central point, the telecom room. So the advantage there is this is a very robust type of network, meaning if that guy with that briefcase knocks out the faceplate on his desk, the only person who's going to be affected by the outage will be him. So it's a very robust. It's the only way that you can take a star network down and affect multiple users is if something happens to the hub, i.e. the hub gets disconnected from the backbone. Or I did a service call one time where the janitor, because the telecom room was in the janitor closet, I guess was having a bad day, and they slammed their cart in the closet and the mop fell off of the cart and hit the power cord out of the back of the switch. Well, all 24 people went down. So you can have a complete failure, but it's a little bit harder. So it's a little bit more robust. And this is also really easy to do moves, adds, changes because you don't have to find that last drop. All you got to know is where is the telecom room? And most likely you already know where that is. And I guarantee you the customer already knows where that telecom room is because they have the key to it. And you have to have the key. Now that is actually a disadvantage because it can be a disadvantage because the telecom room can be locked in some types of businesses. They don't want anybody just walking in that telecom room. So they limit the access to the telecom rooms. Did a project one time for Darden Restaurants in Orlando, Florida. Darden owns Red Lobster and a bunch of other restaurants. They have a multi-building campus down here in Orlando, Florida. Well, in order to get into the closet, you had to schedule one of the building engineers to come by and open the closet for you because he was the only one who had the key. They didn't just give you the key. So if you needed access, you had to know about that in advance and you had to schedule that in advance and hope that building engineer didn't have an emergency call they had to go to that basically took more precedence than you trying to get in that telecom room. So that is definitely one of the disadvantages to a star topology. But everything we do now seems to be done in a star topology. When you're talking about telephony, you're talking about computer systems, cameras, wireless access points, industrial sensors, industrial Ethernet, they all come back to that one central point. Now, when I said a hierarchical star, what I was talking about there, imagine you have a 5-story building. Each of those 5 floors, you have a star configuration. So basically, you have 5 individual networks. Well, now you got to connect them together. That's what that backbone does. So when that backbone connects them all together, you now have a hierarchical star, or some people call them tree stars. It's kind of like almost a combination, really, now that I think about it, between bus and star topology, because the backbone is functioning like a bus network, but the cable out on the floor is functioning like a star. Most common one that we do nowadays. Now you may also, I'm going too fast here, ding, 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 hybrid topologies. Now, another one that's starting to gain a lot of popularities right now is what's called mesh topology. Mesh topology. So on the PowerPoint slide here, you see 6 computers. And if you pick any one of those 6 computers, actually not a good graphic because I just spotted this. In a true mesh topology, computer number 1 actually has 5 cables going to it. 5 individual cables. One goes to cable computer number 2, computer 3, computer number 4, and computer number 5. The advantage here is there's no data traffic issues because there's a direct contact, a direct communications path between that PC and all the other PCs on the network. So you don't have any kind of data traffic issues. It's also one of the most robust because, again, if something happens, it's just going to be that particular device that's going to go down. It's also pretty secure. It's pretty secure because if computer number 1 wants to talk to computer number 3, it will send direct email or direct traffic to number 3. It doesn't have to go through the other PCs to get there, like the bus and the ring have to. So that way, if you're sending a confidential email or confidential file attachment, nobody else even sees that because it's direct communication between those 2 devices. There's a lot of disadvantages to mesh topologies. Number 1, you have to have a large number of I/O ports. So if let's say again, the diagram shows 6 computers, right? You'd have to have 5 I/O ports on each of those computers because you're going to have a cable running to each one of those other computers. That's kind of expensive. They're also pretty difficult to add to the network because if you want to add another drop, you want to add a 7th computer to this mesh network. Well, number 1, you better hope there's enough I/O ports on all the other 6 workstations. And then you got to run a cable, 6 cables to each of those other stations. So again, it's a lot more involved, a lot more cable, a lot more labor, and a lot more testing. Typically, the only place I've ever seen mesh topologies is in a backbone configuration because when they're connecting multiple buildings together, they want to have redundancy and some level of redundancy. Redundancy can actually be done in levels. You can have just a simple, 2 is 1, 1 is none, or you can have 2 different service providers, 2 different cables coming through 2 different paths. So typically, the only place I've ever seen mesh topologies was in backbone configurations. I've never seen a mesh topology for workstations. There are some other topologies out there, especially for building automation. So, for example, the 3 types that you can find in building, and we're talking about building automation, we're talking about cameras, industrial sensors, access control devices, thermostats, lighting, all kinds of stuff, anything with building automation. So there's 3 types of topologies that seem to be used a lot: fixture-centric, node-centric, and daisy chaining. So the first one I'll go through is fixture-centric. So you see 2 diagrams on the screen. The top one is fixture-centric. So each one of those rectangular shapes is supposed to be a light fixture, like a fluorescent light fixture somewhere on the floor. Each fluorescent light fixture has its own cable run directly to it. Think about that. How many lights do you see on a floor in a commercial office building? If you walk into somebody's office, generally there's at least 2 light fixtures in there, sometimes 3, sometimes 4, depending on the size of the room. Each one of those would have to have its own cable, its own 4-pair cable running from that light fixture all the way back to the telecom room. Another type of fixture-centric is a combination fixture-centric / daisy chain. So what you're going to do is you're going to run a cable from the equipment in the telecom room to, for example, that fluorescent light fixture in that office, and then all the other light fixtures in that office, you're just going to run a cable between those. You're creating a daisy chain once you get in the office. Now, the advantage of this type of topology is you have a centralization of all your equipment because all the equipment's back in the telecom room. So that could make you actually not buy as many ports and maybe potentially lower that cost, and also make it easier to maintain because all of the connectivity that you might be doing move, adds, changes to are actually in the telecom room. The disadvantages to a fixture-centric type of topology is you're going to need larger power over Ethernet switches. Well, number 1, they cost more. Number 2, they don't give you the same return on investment that the smaller ones do. And because you have these larger pieces of equipment in your telecom room, which is already probably borderline too small, even if they follow the standards, those power over Ethernet switches generate heat. So now you have to think about additional cooling needed to keep that temperature down low inside that telecom room because you're putting additional power over Ethernet stuff inside of that. Exactly right. So George says Internet of Things, IoT. That's exactly what we're talking about. Internet of Things. The other type of building automation is called node-centric. So with node-centric, what you're going to do is, looking at the top diagram on the PowerPoint slide, you're going to run a cable from the telecom room to a node somewhere out on the floor near the devices that you're going to connect. And then you run a cable from each of those nodes to each one of those devices. Alternately, you can do a node-centric / daisy chain. So the advantage there is you run a cable from the telecom room to the node, and then one cable from the node to the first device, and then you daisy chain the first device to the second device to the third device. Now, the advantage here is you can use smaller power over Ethernet switches. Those are generally more cost efficient, the cost is lower generally for the ports. And you don't have to worry, since you're using smaller equipment, smaller power over Ethernet switches, you generally don't have to worry about increasing the telecom room size or have to worry about adding any cooling infrastructure. Now, the disadvantages to them. Your equipment is spread throughout the entire floor. At least with the fixture-centric, your equipment's all in one room. Here, now you got equipment in the room and nodes spread throughout the floor. Well, if you have to inventory stuff on a periodic basis or do service work, you have to know where each and every one of those nodes are. Each one of those nodes also is going to require an electrical outlet in order for it to work. I know you probably think, well, Chuck, what about power over Ethernet? Well, we can only do up to 100 watts of power right now with power over Ethernet. And those nodes need more power then because they're generally firing up multiple light fixtures or multiple devices. So generally you have to have an electrical receptacle installed in the ceiling somewhere near that. And because of all this stuff, you have to worry about the noise generated from all that active equipment. By noise, I mean EMI, electromagnetic interference. If you want to learn more about EMI, I just published a podcast, an audio podcast on it. Go visit the webpage. I think it was 2 episodes ago. It says, what is EMI? I go through the interfering source, susceptible unit, coupling between the two, and talk about all that fun kind of stuff. Look at that. I did it within 28 minutes. Very cool. So this is why I usually open up the floor to questions. So if you have a question, go ahead and put it in the comment box. Let me take a sip of my water with lemon essential oil. No questions? Nobody has any questions today? Okay, well, if you do think of a question later, absolutely send me an email, chuck@5minutercdd.com, or you can go to the webpage and fill out the contact box or do the voicemail thing that way as well. So you have ways to get a hold of me. Just keep in mind that if you do send me a message through one of those methods, it may take a day or so for me to get back to you because I have a full-time job like everybody else does. And I might be teaching somewhere like I was today. So generally I don't do my 5-minute RCD stuff until after work or on weekends. So I generally won't see it till after hours. And when I respond after hours, you won't see it till the next day. So very good. So somebody said dog. I'm not sure what they mean by dog. Oh, cable dog. Yes, I do have cable dog hats. So you can purchase them. You know, the cable dog is a term for a cable installer. Started back actually in the military days because there's a whole division that does cabling. They used to call them cable dogs, but then it became known as everybody does cabling as a cabling dog. So that's what a cabling dog is. Okay. Anything else, guys and gals? All right. So next Thursday, I'm going to do something a little different. I'm going to open up for 30 minutes worth of questions. So if you have questions, email them to me in advance, and we'll answer all those questions on that 30-minute show. Yeah, February. Oh, yeah, he's talking about my German Shepherd. We have a puppy that was born last night, and we're getting it in 8 weeks, so that'll be February. Dakota Harley. Yeah, very cool. Thank you, George. So until next time, be safe.